Alright, in this class, we want to talk about parallel and perpendicular lines. Parallel and perpendicular lines. Now, we know that two lines are parallel when they run in the same direction, the same distance apart from each other. And parallel lines, they go in an infinite direction, but they never meet. Two lines are parallel when they run in the same direction but never meet. So when we have two parallel lines, if these two parallel lines will never meet, it means that the gradient of the lines are equal. Two lines are parallel if their gradients are equal. So the gradient of line 1 is equal to the gradient of line 2. Right? M1 will be equal to M2. The gradient of line 1 will be equal to the gradient of line 2. So therefore, if I have an equation, y is equal to 3x plus 5. Y is equal to 3x plus 5. That is the equation of this line. If I want a line that is parallel to this line, if I want a line parallel to this, all I need to do is rewrite the equation with the similar gradient. If the gradient of this line is equal to 3, the gradient of the second line will also be equal to 3. So the gradient of a second line will be y is equal to 3x. Only thing we do is change our c value. And the c value could be any number you choose. That line will be parallel because the gradients are the same, plus 6. So these two lines are parallel. These two lines are parallel because their gradients are the same. So if we were asked to find the gradient of the equation of a line parallel to the other, all we need to do is write a similar equation, or an equation with the same gradient, and those two lines will be parallel. Now, when it comes to the perpendicular one, remember, a perpendicular line is where two lines intersect at a right angle. Two lines intersect at a right angle. Now, if we notice that here, line 2 goes in a positive direction, and line 1 comes in a negative direction. So first thing we note about the gradient of perpendicular line is one line has a positive gradient, the other has a perpendicular gradient. Now here, when two lines are perpendicular to each other, the gradient of the first line, the gradient of line 1, multiplied by the gradient of line 2, will always be equal to negative 1. So the product of the two gradients will always be negative 1. So therefore, if we know the equation, or if we know the gradient of line 1, and we want to find the gradient of line 2, the gradient of line 2 will be equal to, if we take our equation, or the gradient over here, right? If we transpose to make the gradient of line 2 the subject of the formula, what we will have is minus 1 over the gradient of line 1. In other words, the gradient of line 2 is the negative reciprocal of line 1. Let me make it easier. All we need to do is upturn and change the sign. So let's use an example. If the gradient of line 1 is equal to 3, we use the same gradient here. The gradient of line 1 is equal to 3. Well, yes, is equal to 3. How do we find the gradient of line 2? remember, m1 times m2 is equal to -1. So therefore, 3 times m2 is equal to -1. So m2, the second gradient, will be, we take over 3, -1 over 3. So look what we did. We upturn, so the reciprocal of 3 is 1/3, and we change the sign. And when we multiply 3 times -1/3, our answer will be -1. So the gradient of a perpendicular line is the negative reciprocal of the gradient of the first line. All right? So let's use this. Let's use this equation. Y is equal to 3x plus 5. And if we want a line perpendicular to this, since this gradient is 3, the gradient of the line perpendicular will be -1/3. So the gradient of the line perpendicular line will be y is equal to -1/3 x plus some number. All right? Let's say 9. All right? So how do we know they're perpendicular? Because the gradient, when we multiply the gradients, it will be equal to -1. All right? So let's do another example. Let's say we have 4x plus, take 3y plus 7 is equal to 0. And we want a line that is parallel and perpendicular to this line. We want a line that is parallel and perpendicular to this. So what we do, we first make y the subject. Remember in our last class, we made y the subject of the formula to find the gradient on the y-intercept. So we do that here again. So we make y the subject. And we make y the subject by taking over our 4x and our positive 7. So taking over 4x, we'll have minus 3y is equal to, when we take over the 4x, we'll have minus 4x. And when we take over the positive 7, we will have -7. So next, we need to take over a 3, minus 3. Since -3 is dividing, since -3 is multiplying, when it goes over, it will divide throughout. So y will be equal to -4x over -3 minus 7 over -3. So negative and negative will give us a positive. So y is equal to 4x over 3 plus 7. So if we want a line parallel to this, a parallel line will be, since this gradient is 4 over 3, a parallel line will have the same gradient. So therefore, we will have a line parallel will be equal to 4x over 3 plus some other value for c, some other number other than 7. So let's say 30. So these two lines are parallel to each other, right? These two lines will be parallel. If I need a perpendicular line, right, what do we do? Remember, we upturn the gradient. Since this gradient is 4 over 3, a line parallel to it will be 4 over 3 too, but a line perpendicular, we find the reciprocal of 4 over 3, which will be 3 over 4, and then change the sign. So a line perpendicular will be y is equal to minus 3 over 4x, right? Upturn, we change the sign, take some other c value, take 8, right? What matters here is the gradient. This will be parallel to this since the gradients are the same. These two will be parallel since the gradients are the same. Alright? But this one will be perpendicular. This will be perpendicular. Since the gradients, let's multiply it and see that we get our negative 1. 4 over 3 times minus 3 over 4 cancels out. This will cancel out here, so we'll have negative 1 over 1, which is equal to minus 1. So when we multiply the two gradients, our answer is negative 1. So those two lines are parallel. So if we're asked to find a parallel line, all we need to ensure is that the gradients are the same. If we want to find a perpendicular line, what we have to ensure is that when we multiply the first line, multiply the gradient of the first line times the gradient of the second line, our answer is negative 1. Or find the negative reciprocal. Upturn the number and change the sign. If the gradient is positive, it becomes negative. If it's negative, it becomes positive. So that is how we deal with parallel and perpendicular line. That's how we find the line parallel or perpendicular to a given line. What we will do in our next class is do some exercises where we find the line parallel or perpendicular going through a particular point. Alright, now we're going to solve this equation where it says find the equation of a line parallel to y equal minus 4x plus 8 and passing through the point 2, negative 7. So first of all, we know that the equation of the line is given as y is equal to minus 4x plus 8. Now we also know that a line parallel to that will have the same gradient. So first, let us identify what is the gradient here. So the gradient of that line will be m, will be the coefficient of x. Since y equal mx, this m represents the gradient. So the gradient of this line is negative 4. And we remember from our last class, a line parallel to it will have the same gradient. So the gradients of the line are, since the gradients of the lines are the same, they are parallel to each other. All we need to do now is find the y-intercept. So using this point here. So we have one line that passes through the 8 on the y-axis, and we need to find the gradient of we know the gradient of the second line. What we need to do is see where it passes through the y-axis, right? So we use this point. Y is equal, all right, y in this case will be minus 7. We know that x here is 2, so the gradient is 4, so minus 4 times 2 plus c. So multiplying, we'll have minus 7 is equal to minus 8 plus c. Taking over our 8, minus 7 plus 8 is equal to c. Therefore, c is equal to 1. So it passes through the point c, or passes through the y-axis at the point 1. So therefore, the equation of the line parallel to this and passing through this point will be y is equal to same gradient minus 4x plus 1. So these two lines are parallel to each other. This one passes through the y-axis at 8. This one passes through the y-axis at the point 1. So let's now look at our next question. Find the equation of a line perpendicular to y is equal to 2/3 x plus 7 and passing through the point 4, 9, negative 3. So we know the gradient of this line. We know gradient of this line is, gradient 1 is the coefficient of x, which will be negative 2/3. So the first thing we need to do is find the gradient of the line perpendicular. Now remember, if the line is perpendicular, it is the negative reciprocal. So we upturn and change the sign. Or when we multiply the two lines, the two gradients, our answer is equal to -1. So the m1, which is -2/3, times our second gradient, m2, will be equal to -1. So if we have to work this out to find m2 will be equal to -1. When we take this over, we upturn it, which will be times 3/2, times -3/2. So the negative and negative will give us a positive, and our answer will be 3/2. So we upturn and change the sign. So the gradient of the perpendicular line will be 3/2. So using that now, and substituting our gradient and the points, we can find where it cuts the y-axis, the y-intercept. So we're using this point. -3 is equal to, our gradient here will be 3/2. That's the gradient of the perpendicular line. We're using the point for -3, so x is 4 plus c. So reducing this, 1, it was 2. So -3 is equal to 6 plus c. Taking over our 6, -3 takes 6 is equal to c. So that gives us -9 is equal to c. So now, here we know the value of c. Now just to rewrite our equation with the gradient and the y-intercept. So y is equal to 3/2 x plus t 9. So the gradient or the equation of a line perpendicular to y equal -2/3 x plus 7 passing through this point, the equation of that line is 3/2x minus 9. All right, in our next class, we will find the perpendicular bisector of a line. The perpendicular bisector of a line. In this class, what we want to find is the perpendicular bisector. The perpendicular bisector. So let us talk more about what is the perpendicular bisector. Now, if we're given a line AB, the perpendicular bisector cuts AB at a right angle at the center or at the midpoint of AB. The perpendicular, remember, perpendicular means a right angle, two lines that form a right angle. The bisector means, bisect means to divide in half, to bisect. So the bisector, where the line, the perpendicular line bisects AB, it is at the midpoint of AB. So the midpoint of AB is found on the perpendicular line. It's that point which it passes through. So what if we're to find the perpendicular bisector? The first thing we need to do is know the angle or the gradient of AB. Let's find the gradient of AB. So the gradient of AB, the gradient, remember gradient y2 minus y1 over x2 minus x1. So here we have our x1, y1, x2, y2. And we can substitute. So 3 take 7 over 10 take 2. 3 take 7 over 10 take 2. So our gradient will be, that will give us -4 over 8. -4 over 8. So our gradient will be, when we reduce that, will be -1/2. So we have our gradient of the line AB. Now, to find the gradient of the perpendicular line, find the gradient of the perpendicular line, we do it the same way as we did before. Now, if this line, if line AB is, the gradient is negative a half, it means the line, the perpendicular line. Remember how to find the gradient of a line perpendicular. What do? We upturn and change the sign. We upturn and change the sign. So since this line is, the gradient of this line is a negative a half, remember the gradient of the first line times the gradient of the second line when two lines are perpendicular will give us negative 1. So if the gradient of the first line we have is negative a half times the gradient of the second line is equal to negative 1, it means that the gradient of the second line, we take this over, upturn and multiply negative 1 times 2 over 1 times 2 over 1. So negative 1 times 2 over 1 will give us 2. So the gradient of this line, we upturn it. When we upturn a half, we will get 2. And then we change the sign, which will give us a positive. So here we have the gradient of the perpendicular line being 2. So next we need to find the value of C. Because remember, y equal mx plus c. So we have the value of m, which is the gradient. Now we need c. So we need a point on the perpendicular line. Now a point on the perpendicular line will be the midpoint of AB, right? We cannot use 2, 7 because 2, 7 will be found there and 10, 3 will be found here. It is not found on the perpendicular line. So we have to find a value on this perpendicular line, and that value will be the midpoint. So we need the midpoint of AB. So reminding ourselves how we find the midpoint will be x1 plus x2 over 2 and y1 plus y2 over 2, which will give us x1 will be 2 plus 10 over 2, and y1 and y2 will be 7 plus 3 over 2, which will give us 12 over 2 and 10 over 2. So the midpoint will be 6, 5. That's the midpoint. So we will use the midpoint to find the value of C. We're using our midpoint to find the value of C. So we know our gradient is 2. So y, which will be 5, 5 is equal to 2 times 6 plus C. So 2 times 6 will give us 12. So 5 plus 5 is equal to 12 plus C. Taking over our 12, 5 take 12 gives us C. So minus 7 is equal to C. So our equation will be, the equation of the line will be y is equal to 2x take 7. Y is equal to 2x take 7. Right? That is the equation of the line perpendicular to AB, the perpendicular bisector to AB. Now what I will encourage you to do is practice. Practice these questions from your worksheet. When you finish with practice, check your answers, and if you have made some error, recheck your working. If you still don't understand, go back to the videos, see how it is done, and keep practicing and practicing until you get them correct.